Hello everyone, today we're going to be talking about mesh analysis. Let's dive right in. So here is mesh analysis. For mesh analysis, I'm going to be using this problem shown here in my OneNote, and I will be explaining the steps that are necessary to take, generally speaking. Okay? First, so when we do mesh analysis, you usually want to find all mesh currents. Okay? And these are the steps. First step, if not drawn, then label all your mesh loop currents. Okay? There's some conditions though. If you have a current source, all mesh loop currents, MLCs, will follow its direction. If one is already drawn, all must follow its direction. Otherwise, pick a direction and all must follow it. All must follow it. There's only two directions to choose from: clockwise or counterclockwise. That's it. Step 2. Draw terminals for each resistor so that voltage is being dropped across each resistor. I will show that in a second. In fact, let's do it now. Step 1's already done for us. They're shown in yellow. Draw terminals for each resistor so that voltage is being dropped across each resistor per mesh loop. This is what I mean. Let's do I1. This is mesh loop number 1 called I1. For voltage to be dropped across R1, it would be positive minus as drawn because I1 is going clockwise, so it'd be going into the positive, out of the negative. That's going down a mountain. Same thing for R2. Down the mountain. You're going down. Top, positive terminal, to negative, bottom terminal. Okay? And so this is purple. Purple is going to be representing that of I3. It's a little too thick. Thickums. All right. I3, same thing. You want it to go down or voltage drop across each resistor. I understand R2 currently has 4 terminals attached to it, but that's because R2 is experiencing 2 mesh loops. So it's going to have 2 pairs of terminals. Okay? Now, what about the other one? Let's go over it. I2. I2 will be going plus to minus because that's the only way for the voltage drop to go through R3. Okay? So R3 also has 2 pair of terminals attached to it because R3 is in the worlds of mesh loop 2 world and mesh loop 3 world. Cool? That is completing step 2. Then, for step 3, with respect to the terminals complete KVL per mesh loop. Unless if mesh loop has a current source set MLC equal to current source. Current sources current. Okay. So that means for this case in our circuit, I2 is equal to IS because I2 is flowing in the same direction of IS. If you take your pen, let your pen represent I2. I2 literally goes through IS and is going in the same direction. This also is analogous and comes from step 1 under the condition that if there is a current source in your mesh loop, then all mesh loop currents will follow that direction. So I2 is equal to IS for that scenario. So now we need to do the KVL per mesh loop for all other loops, which is I1 and I3 world. Well, mesh loop 1 world and mesh loop 3 world. So I2 is equal to IS. KVL at mesh loop 1 world is what? We're going to have to zoom out a little bit and go up and down. I'm sorry. I would like to point out that in mesh loop 1 world, with reference to the red colors, I'm going up V1, down R1. I1 goes down R2, but I3, with respect to the red colored terminals, goes up R2. Going up VS, going down R, I'm going down, where is it? I'm going down R1, and I1 is going down R2, but then, going back to my drawing, I3 is going up the red terminal mountain of R2. That's why I have plus I2 R2. All of this is equal to 0 volts. Then I do the KVL at mesh loop 3. Okay, so for this one, let's start with RO. I3 is going down RO. I3 is going down the purple terminals of R2, but I1 is going up the terminals of R2, the purple ones. R3. I3 is going down the purple terminals of R3. However, I2 is going up the purple terminals of R3. Therefore, I'm going down I3 RO. I'm going down R2, but then I2 is going up the terminals of R3, the purple ones. And then I was going down, I3 was going down the purple terminals of R3. But I2 was going up the purple terminals of R3. Wait. Oh. And I forgot to mention that V2 is existing here. So I3 goes down V2. So we can just list that here, minus V2. All of this is equal to 0 volts. If you need to pause or rewind, go ahead. This is YouTube. So let's just reiterate mesh loop 3. Okay. It's going to be minus I3 times RO because you're going down the purple terminals of RO. You're going down, so it's minus I3 using the purple terminals of R2. And then you're going up. I2 is, sorry. I1. I1 is going up the purple terminals of R2, then I3 is going down the terminals of R3, but I2 is going up the purple terminals of R3, and then I forgot to add V2 when I was going clockwise, but I could just put minus V2 here because I3 is going down the terminals of V2. All of this is equal to 0. Let's zoom in. We have 3 equations and 2 unknowns because I2 is equal to IS, which is equal to what? Oh, it wasn't provided to us. Actually, it was. It's just that it wasn't explicitly stated, but it was. 1 second, I'm gonna get the values. Well, if you needed to get, the values weren't provided, but you assume you know IS, all R's, and all voltage sources. If you did, then you'd be able to solve for I1, I2, and I3. Okay? So this is how you would solve I1, I2, and I3. Okay, let's do an example. All right, the example that I want to go over is, I'm going to call it (293). Okay, I think that's a good name to give. Just trying to check here if that's the name I want to give it. 293, yes. Okay, and for 293, we are dealing with this circuit. Okay. So this is R2, this is R1, this is IS, this is VS, this is R3. We're told that minus plus is here for what they call V, for V3, okay? Actually, they call it VR3. And we are told that IS is equal to 8 milliamps. We are told that R1 is equal to 400 ohms, R2 is equal to 2000 ohms, R3 is equal to 1500 ohms, and VS is equal to 9 volts. Let me rewrite that VS for you all. All right. So they also say draw a current called I1 that goes from left to right, called I1. All right, so this is the problem statement, and this is the drawing that you should be able to have from the problem statement. And the first question is, question 1, what is I1? And they want it in units of milliamps. So let's do our steps. Steps 1, I would like to know what I1 is in units of milliamps, please. Okay, cool. Let's do step 2. Step 2 is, let's use mesh analysis to get our answer. So it's going to require some drawings. Mesh analysis, go through the steps. We have to draw out and label our mesh loop currents. I see a current source, so we all have to go counterclockwise. I'm going to call this I2. I'm going to call this one I1. Just going to notate here that I1 is in fact equal to IS, okay? I mean I1. I1 is equal to lowercase. You know what? Let's just let's make our life easier. Let's just call it I1, and let's use lowercase letters. So I use colors. I1, I2. Okay, so we have labeled our currents. Cool. Now we need to label our terminals of the resistors using the notations of the directions of the current so that there's a voltage drop. Okay, so for there to be a voltage drop across R3, it would have to be drawn as plus on the left, minus on the right. Why? Because I1 is going counterclockwise. So for the voltage drop to be across R3, it has to enter the positive terminal and leave the negative because that is going down a mountain. Okay, for I2, plus, minus, plus, minus, plus, minus. So for I2, you're going down R1 mountain because you're entering the positive, leaving the minus. For R2, you're going down the mountain, so it's positive at the top, minus at the bottom. And then I forgot to mention with the green, I1, mesh loop 1 world, you'd be going down the mountain, so plus, minus for R2. Okay? For those who may or may not have forgotten, a voltage drop exists when you are going down the positive to the negative terminal for a resistor. That's a voltage drop. Okay? So we have that drawn. Cool. Now we need to do KVO. KVO at, let's do loop 1. So KVL at loop 1, how is that going to be? Well, that's the summation of voltages is equal to 0. So let's just draw that out. So it'd be minus Vs minus I1 times R3 minus I1 times R2. But I2 is also going through R2. And I2 is going to go through the green mesh loop 1 terminals. That's positive I2 times R2. All of this is equal to 0 volts. Again, we are doing KVL at loop 1 with respect to the terminals in that mesh loop world. Okay? Then we do KVL at loop 2. Wait, you don't need to do it. Why, Mr. C? Because the rules said that if a mesh loop has a current source, instead of doing a KVL, you just need to set the mesh loop current equal to the current source's current. So in this example, I2 is equal, lowercase I2. I2 is equal to IS. So now, if you look at this math, you have two equations, but only one unknown. And that unknown is I1. And by completing high school level algebra, you should be able to get that I1 is equal to 2 milliamps. Because you know Vs, you know R3, you know R2, you know Is. So you should be able to have two equations, one unknown, solve for I1, it's 2 milliamps. Now, second question. What is VR3 in units of volts? Is it volts or millivolts? Volts. Okay. So what is it? Okay. Let's zoom in. I'm zooming in. I'm zooming in. Oh, the terminals are drawn like this for VR3. Okay, so if I'm zooming in, I notice that the positive terminals on the left, negative terminals on the right. Okay, and this is VR3. This is how we're measuring VR3, and I1 is going from left to right. So I'm just going to redraw that drawing. Call this VR3, and current is going this way, called the I1. For those who don't like the way this is laid out horizontally, let's just make it vertical. That's fine. Call this R3, call this VR3, and current is going down. Using Ohm's law, how can you do this? So we're solving for VR3 in units of volts. Ohm's law states that VR is equal to IR times R if and only when you have this drawing, which we do. So VR3 is equal to what? It's called I1 times R3, which is 2 milliamps times 1,500 ohms. That gives you 3 volts. All right. Thank you for tuning in.